Hi, today we are going to learn 13.3 day 1, the base e, and we will take a look at the function where the base for an exponential function is e. We have looked at functions where y is equal to 2 to the x, 10 to the x. We even look at 1/2 to the x. These are all exponential functions, growth or decay. But now we're going to take a look at when the base is actually e. And so we will take a look at where the number e comes from. Well, it comes from this expression when we have the increase rate when it goes all the way up to infinity, and then it approaches this decimal value of 2.718. So this number, we just call it e for short. So hence comes the equation f of x equals e to the x. We can also access e on the calculator using e to the 1 power, that's approximately 2.71828. So this whole thing is equivalent to e. As you can see, e is an irrational number because it does not stop at the last digit here. It keeps going. And now that we know that what e is, we are going to investigate the first example. So we have the first basic graph of f of x equals e to the x. And so when x equals all these values here, we're going to take a look at the value of the function. So we have e to the negative 10. That's going to be a very, very small number. It's going to be 1 over e to the 10, which when you punch it into the calculator, you're going to be getting something like this, 0.00045. E to the negative 1 is basically 1 over e, and that's going to be 0.37. And e to the negative 0.5 will give you 0.6, and anything to the 0 power equals 1, then the rest of the values can be easily entered into the calculator. E to the 1, it should be 2.718. And e to the 1.5 is about 4.5. E to the second is about 7.4. So those are the values. As you can see, the table of value is getting bigger as e is getting bigger. So let's take a look at the domain. The domain of the function is Oreos. When you connect all of these, you're going to have something that is in an increasing value, and the y-intercept, notice, is still 1. So if you continue the pattern, this will be e to the x right here. And the range is, as you can see, is above the x-axis, so we can still follow it will still follow the general guideline for an exponential function. The range is greater than 0. Y-intercept, again, is going to be when x equal to 0, and that's 1. And as the value of x approaches infinity, which means as you go to the right, the function is going up to infinity. And as the value approaches the negative infinity, the left side, the value approaches 0. So those are the characteristics for this function. And then the last one is the horizontal asymptote. We do have a horizontal asymptote at the x-axis, which means y equals 0 is the name of the line. So that's the basic y equals e to the x function. And here is the general exponential function involving the base e. It looks exactly like the one that has base b, which means it can be any number, but specifically e means just the number e, 2.718. And all of the other numbers indicate the same transformation. So those are the transformations, and the domain range is here. And we do have an asymptote, horizontal asymptote at the last number k here. So let's take a look at the reference points are 0, 1, and 1e. Those are the two reference points that we'll be using over and over to graph the functions. And now let's actually take a look at the first equation that we're going to graph. So taking a look at the equation, we have the transformations are vertical compression of 0.5, and we have 4 units to the left and 1 down. So those are the 3 transformations. Identify A, B, H, and K. So A equals the number in front, so A is equal to 0.5. B is the base, which in this case is E. H is the number that is with X, so that would be -4 because it is minus 4. So notice that is a minus 4 right here. So H equals -4, and K is just a number in the back, which is -1. So step A is done. Next, we have step B stating the domain and the range and horizontal asymptote. So the domain in this case is Oreos. Range is going to be y greater than the horizontal asymptote, which is -1. And we have a horizontal asymptote at y equals -1. In fact, we are going to draw the horizontal asymptote, which is right there. Next, to finish the graph, we need to identify the reference point. So let's go ahead and draw our reference point. The only one that's going to affect the x is the horizontal shift of 4 units to the left. So to the left is x minus 4. So remember, moving to the left is minus, to the right is add. And the y value is going to be read as 0.5x minus 1, 0.5y minus 1. And we're going to enter our two reference points, 0, 1, and 1e, into the equation. And let's go ahead and find the values. 0 minus 4 is -4, and 1 minus 4 is -3. And then the y value is going to give us -0.5. And we need to substitute 0.5 times e minus 1. And that should give you a value of approximately 0.36. And let me just verify that. So we have yes, 0.36. And we're going to graph those two reference points. At -4, it's a half. And then at -3 is 0.36. So you can see that the number is actually -4 is at -half, and at -3 is 0. So the numbers are getting bigger, and it follows this graph pattern right here. And it's still an exponential growth because the base is bigger than 1. So e is actually greater than 1 and should follow the pattern of a growth. And that is the end of this problem. We're going to try another one, so make sure you pause the video at this time and do the problem first before you look at the solution. So again, we're going to name the transformation. Notice this one has a negative in front, so it's a reflection across the x-axis. That's the first transformation. Next, we have 2 units to the left and then 1 unit down based on the k value. And so identifying A is going to be -1. B is also E, the base. H equals -2. Again, it's a -2. And K equals -1. Next, stating the domain. Domain is still going to be all reals. And the range is going to be, because this is reflected, so from a growth, it's going to be reflected. It's going to be below the horizontal asymptote, which is y less than -1 in this case. And then the horizontal asymptote is going to be y equals -1. And we're going to draw that right now. So here is the horizontal asymptote. Identify the reference point. So we're going to use the reference points again for the x. 2 units to the left, again, it's an x minus 2. And then we got -y minus 1. That would be the y values. And the two reference points are 0, 1, and 1e. And we have the values of -2, 1 for x, and -2, -3.7 for the y value. And we're going to graph that here. So at -2 is going to be at -2, and at -1 is going to be at -3.7. So you can see that the graph is going to be this way, facing down. And like we said, it is following the reflected across the x-axis rule. So that is the end of the problem. Here's a discussion. What is f of 0, and what does this tell you about the graph of f of x equals e to the x? So f of 0 is equal to e to the 0, which will give us a value of 1 because anything to the 0 power is 1. And this tells us that the y-intercept is 0, 1. So that indicates the y-intercept. And that is the end of the lesson. And you may go ahead and get started with your assignment, book set, and HIW. And don't forget, take notes for 13.3 day 2. And finally, Alex.